Okay, so we're continuing 1.8 and we're formally defining now the notion of a substitution instance, and we're going to look at an example to make sure we understand the definition. So hopefully based on the last video you have an intuitive idea of what a substitution instance is. Remember, it's a proposition that is a substitution instance of a form, not the other way around. So here's the formal definition, and then we'll look at some examples to make sure we understand all the aspects. A proposition is a substitution instance of a form if and only if the proposition results from replacing every propositional variable token in the form with some proposition, provided that if multiple propositional variable tokens of the same type appear in the form, then each such token is replaced with the same proposition and no other changes are made. Okay, so that's a lot of jargon. All of that technical terms were defined in the previous video. Using that, pause now and see if you can't tell me which of these 5 propositions is a substitution instance of this particular form. This one right here, not any other. Which of them is and which of them is not a substitution instance of this form based on this definition. We'll come back together and do it in a second and unpack this. But pause now and give it a shot. Okay, so hopefully you've had a chance to take a look at this. Let's go through this together. So this here is not a substitution instance of this form. Okay, and it's not because it says that the definition requires that the proposition that results from substituting into the form has to replace every propositional variable token. And this token of the Q here did not get replaced. So that's automatically not going to be a substitution. Every single token of the form has to be replaced, okay, with some proposition. All right, so let's take a look at the second one. So we'll put this up here. No, not a substitution instance. Okay, let's take a look at this next one. Is this a substitution instance? It looks like it might be, but in fact it is not. This is not a substitution instance of this form, okay? This proposition replaces every single token of the form, but it assigns different values to P. So P appears here and P appears here, so it should be A in both cases or else C in both cases, but here P was A and here P was C, and that is not allowed. If multiple propositional variable tokens of the same type, P and P in this example, appear, then each of them has to be replaced with the same proposition. So this is not a substitution instance of this form. Now notice, this is in fact a proposition, but it is not a substitution instance of this form. Now is this guy here, 3, this proposition, and it is a proposition, you could do a proposition tree for it. Is it a substitution instance of this form? The answer is that it is not. It is not a substitution instance of that form. Okay, it might be a substitution instance of a different form, but it's not a substitution instance of this form. Everything's fine, right? All the letters are replaced. P and Q have different values. That's fine, but it does make, proviso B here says no other changes can be made, and all of a sudden this if-then became an and that's making a different change, and so that is prohibited, and therefore this is not a substitution instance of this form. All right, let's take a look at this guy. Is 4, this proposition, is that a substitution instance? You bet it is. It is a substitution instance, right? Makes no other changes. Propositional forms of the same type are replaced with the same thing, namely A, and Q takes a different value. That's perfectly fine. All right, what about here in 5? Is that a substitution instance of that form? The answer is yes, it is. It is absolutely, okay? No other changes are made. Everything is replaced. And in this case, P and Q have the same value. That is absolutely allowed. Our definition does not restrict that. So that's that case. Let's look at another example. This one tougher. So same problem, basically. You're going to tell me whether or not each of these propositions is or is not a substitution instance of this form. Right? So this is a bit more complex. Notice Q appears twice here. Okay, and the main connective is this guy. Right? So we're going to go ahead and go through these together slowly. Now, if it is if this proposition is a substitution instance of this form, I want you to tell me what the values of P, Q, R, and S are in that particular case, and so on for all of them. So that's this problem. Go ahead, pause now, and give this a shot. Hopefully you've had a chance to think this one through if you were able to get it good, right? This one's a bit of a toughie, all right? And it's designed that way because I really want to emphasize that you understand this notion of a substitution instance. Okay, so we've got this pretty complex form here. Now, is 1 a substitution instance? Is this proposition a substitution instance of this form? And the answer is yes, it is. P is A, Q is B, R is C, S is D. And notice Q appears twice as B in this. Right? Nice. And notice on C, R does not include the negation there. Right? The negation's right there. The negation's right there. R is just C. If you copied and pasted into it, would it result in this? That's the concept being defined. Okay? All right. So let's take a look at the second one. Is that a substitution instance of this? And the answer is no, it is not. Can you figure out why? I mean, what's wrong with it? The answer is that Q takes different values, right? So Q appears here, and here it's C, and here it's B. It's got to be both B or else both C in each of them. It's not a problem that Q could be C and then R could be C as well. That's not an issue. The issue is that Q appears twice here, and so the same thing has to appear for the Q there. All right, what about 3? 3 is not a substitution instance. And the problem is that there's no ampersand in the antecedent here. You've got the not, that's fine, but where's the and Q part, right? It's not there. So no other changes can be made, right? You're losing all this information here. There's got to be an ampersand there. 4, is that one? Is that a substitution instance? Yes, it's a bit of a mess. Here's the main connective, here's the main connective, here's the negation outside, here's the negation outside. Now P is A or B, Q is C if and only if not D, right? And you've got the and connecting them. Then Q appears again, C if and only if not D, if and only if, here's this if and only if and only if, not R, right, which is just plain old F, or A or B. In this case, S and P take the same value, and that's perfectly fair. Okay? All right. Finally, the fifth one. The fifth one is easy to spot because the main connective of this is the if-then. The main connective of this is this guy, the negation, right? So remember our work on main connectives. And since they have different main connectives, some other change must have been made, and therefore this is not a substitution instance of this form. All right, hopefully you've got that down. All right, so now I want to define another idea, and it's this big, nasty definition. But it's actually a lot easier than it looks. It just takes a little bit to specify the concept formally, okay? So I want to start over here on the right-hand side where we're just looking at an example. Here's one interesting thing about substitution instances of forms, okay? One proposition, notice this is a proposition, not a form. This proposition can be a substitution instance of all kinds of forms, right? So, look, it's a substitution instance of this form. This is a form. Is this a substitution instance of it? Yes, right? P is just the whole thing. P or Q, well, P is just this part. Q is just this part, right? It's a substitution instance of all of these different forms here. Now, what we want to do is we want to single out one of these forms, one of these 7 forms, okay, as a special form with respect to this proposition. We want to say, hey, you know what? This proposition is a substitution of this form, but this form isn't really a nifty form for this proposition. This form, however, is a nifty form for this proposition. We want to say this form is more special than these other forms, of which this proposition is all substitution instances of. We're going to call the nifty form, the special one that we want to single out for special attention, the characteristic form of a proposition. So what's the basic idea? Well, the basic idea is this, right? All of these forms of which this is a substitution instance of lose information about this. So P just represents this as atomically without any kind of logical structure. But look at all this logical structure. You've got a disjunction. The left disjunct is a conjunction. The right disjunct is also a conjunction. It's got a negation going on there. But if we represent it with just P, we lose all of that information, right? So we want to preserve as much information as possible is the idea. P or Q? Well, this is a substitution instance of P or Q. That's true, but again, you lose information. It has more than one. It doesn't represent it as atomically, as structuralist the way one does, but it is sort of signifying that the left side doesn't have much structure and the right side doesn't have much structure, right? Again, building in complexity, this one preserves even more information, right? You've got the main connective, the left side has a logical structure, but the right side has no logical structure. So it represents more logical structure, right, this form, than this one does. Okay, and that's the big idea, and so on all the way through. And then you can see you're just sort of ramping up in logical structure for which this represents. Now, let's take a look at 6 and 7 here, because this is important. Now, both of these represent like the totality of logical structure for this proposition. That's true. But A appears twice, and 7 has P appearing twice, whereas 6 uses P and R, right? So it's better, in addition to introducing all of the logical structure, to represent the same proposition with the same propositional form. So we would prefer 7 to 6, and that's what this definition is saying. It's a big, sloppy, messy way of saying that, okay? So the basic idea is that you want to preserve as much logical structure as possible, and you want to use the same propositional type for all of the same propositional form types, all right, as in 6 and 7. So with that, basically what you're doing is you're saying, okay, here's my proposition. What's its characteristic form? Well, the characteristic form is just you replace all the A's, the B's, the C's, the D's with lowercase p, q, r, and s's. You change nothing else, and if the same type appears multiple times, then you use a same type propositional variable. For example, the A appears twice, so you're going to get the P twice, and that's all you're doing. You just read it left to right, P, so you'd write left parenthesis, P, ampersand, right parenthesis, the Q in between, wedge, left parenthesis, right? We're going to need a new one, so we're going to go with Q, ampersand, not, and then the same one, P, to begin with, and you're going to get this, and that's going to be the characteristic form by definition, and that's all this says. You're just literally swapping out the capital letters for lowercase letters, and the result is the characteristic form. So you give it a try now. These are all propositions. Find me the propositional form of each of these. We'll go through it together in a second. Pause now. Okay, hopefully you're able to work it out, but you're literally just going across your proposition and swapping out for lowercase letters, making sure you use the same propositional form for the same letters. A, B, C, P, Q, R. A, B, C, P, Q, R, right? And notice you're preserving everything else along the way, right? Not A, B, C, P, Q, R, right? Everything's got to be the same throughout. No other changes are allowed, right? C, if C, then D, right? These show up same letters again and again, so you got to make sure you control for that, all right? Finally, A, P. Easy peasy. That's how it's done. All right, logic fans, that's it for this one, and we'll see you on the next one. Keep it up.